And let's have a look at these examples. So number 1 says, for what values of x? Now, when you read that, hopefully solve for x comes to mind. For what values of x? Solve or find x. Is this curve concave up? Okay, so what is this curve? This curve is a positive cubic. A positive cubic looks like this. And yes, we can see that it is concave up in the second part of it. What do we know about concave up? We should state that. A function is concave up if, and in this case I've used the y notation, y double dash for derivative, because the original function was labelled y. So we know that a curve or a function is concave up if its second derivative is positive. So given this is the original curve, I'm going to find my second derivative. So y dash is just using our differentiation process. Differentiate again, 6x plus 2. Now solve my second derivative greater than 0. Nice linear inequality. The 2 goes to the other side, becomes a negative. Divide both sides by 6. X is greater than negative 1/3. Therefore, the function is concave up when x is greater than negative 1/3. Now I'll see if this works. I went to Wolfram Alpha. I asked it to sketch x cubed plus x squared minus 2x minus 1, the original function, and hopefully there you can see that at about here the graph converts from concave down to concave up, and so yes, thereafter when x is greater than negative 1/3 we have concave up. The second example is very similar, just asking for when a particular function is concave down. So find the domain this time. Domain just means x values. So we read the words this time. Well, we're still thinking the same thing. I've got to get an expression about x because I'm going to solve for x. What's my expression going to be? Well, because the question asks about concavity, my expression is going to be an expression for the second derivative. If the question was about the actual slope of the curve, I would be focusing on the first derivative because that's what the first derivative does. Tells me about the slope of the curve or whether the curve was increasing or decreasing. The moment the question talks about concavity, you shouldn't be able to make the connection now. You're going to have to pursue the second derivative. And concave down, well, you start off, a function is concave down if the second derivative is less than 0. If in every question you make yourself write this, it becomes automatic. You learn it really quickly, really, really quickly. Think about what you're writing, think about what the question's asking, think and realise this is a fact you've got to know off by heart. So, yeah, get writing it every opportunity you possibly can. We're given, and what we can see here is, again, we've got a nice positive cubic. Where will it be concave down? Well, it'll be concave down up until a certain point. So we want to establish what that point is and say all x values less than that. So that's going to be our aim. First derivative, second derivative, hope I haven't made a mistake. Sorry, function, first derivative, second derivative. Solve is second derivative less than 0. 6x less than 14, x is less than 2 1/3. I didn't graph this one, but I'd be expecting on the original function that this point occurs at x is 2 1/3, and we state that the function f of x is concave down when x is less than 2 1/3. I'm going to stop this video there and talk about points of inflection in more detail in the next video.